Hi guys, this is Pavan, BSc MPCS final year, Tara College. Today's my topic is solid crystals. Crystal. Crystal is nothing but perfect order. In a crystal, atom or molecules are arranged in a perfect order is called the crystalline solids. పర్ఫెక్ట్ ఆర్డర్ అంటే ఇక్కడ పిక్చర్ చూడండి, ప్లెయిన్ గా ఒకటి తర్వాత ఒకటి పర్ఫెక్ట్ ఆర్డర్ లో ఉంది. దాన్నే క్రిస్టల్ అంటారు. దెన్ నెక్స్ట్ ఎమార్ఫస్. ఎమార్ఫస్ is నథింగ్ బట్ డిసార్డర్. In amorphous solid, atoms or molecules are arranged in a random order is called the amorphous solid. Amorphous లో ఆటమ్స్ అన్నా మాలిక్యూల్స్ అన్నా ఆర్డర్ లేకుండా ర్యాండమ్ గా అక్కడొకటి ఇక్కడొకటి ఇక్కడ ఇలా ఈ పిక్చర్ లో కనిపిస్తున్నట్టుగా డిఫరెంట్ డిఫరెంట్ ప్లేసెస్ లో అరేంజ్ చేసి దాన్ని ర్యాండమ్ గా అరేంజ్ చేస్తే దాన్ని amorphous solid అంటారు. దెన్ నెక్స్ట్ టైప్స్ ఆఫ్ క్రిస్టల్స్. There are two types of crystals. They are single crystal and polycrystal. Mm, In case of the single crystal, the entire solid consists of the only one crystal. సింగిల్ క్రిస్టల్లో మొత్తం సింగిల్ క్రిస్టల్లో ఎంటైర్ సాలిడ్ ఉంటది. అందులో ఓన్లీ వన్ క్రిస్టల్ ఇన్ ఓన్లీ వన్ క్రిస్టల్. The next polycrystal. Polycrystal is an aggregate of the many small single crystal separated by the well-defined boundaries. ఇక్కడ చూడండి పిక్చర్ లో పాలీ కాబట్టి డిఫరెంట్ డిఫరెంట్ షేప్స్ లో క్రిస్టల్స్ అరేంజ్ చేయడం జరిగింది. దెన్ నెక్స్ట్ క్రిస్టల్ స్ట్రక్చర్స్. క్రిస్టల్ స్ట్రక్చర్. క్రిస్టల్ స్ట్రక్చర్ is nothing but the arrangement of the combination of the lattice and bases. What is lattice? Lattice is the nothing but arrangements of the points. The periodic arrangements of the atoms in a crystal is known as the lattice. The arrangements of the points is called the lattice. Um, lattice represented the diagram is ఇక్కడ కనిపిస్తున్నట్టు స్మాల్ డాట్స్ 1 by 1 straight lines dots are the space lattices. Bases. Basis is nothing but the set of one or more atoms about a lattice point is known as a basis. The crystal lattice together with the basis give the crystal structures. Crystal structure equal to lattice space basis. Like this. See the figure like this to arrange the crystal structures. Then next, Bravais lattice. Bravais showed that there are only 14 ways of the arranging points in a space to the environment to look at the same from each point. The lattice are called the Bravais lattice. Bravais lattice show the only 14 ways of the arranging the points. They are first one is cubic crystal. In case of the cubic system, there are three Bravais lattices, each of which has the same collection of the symmetry elements and the lattice points. They are primitive, body centers, phase centers. Primitive is represented the letter P, body center represented the letter I, phase center represented the letter F. To see the figures, primitive crystal, primitive crystal, then next body center crystal. To locate the point is center and phase center to locate them. Uh, one for the phase center and the four corners. In this crystal, all of the three length of the unit cell are equal and are at the right angles to each other. A equal to B equal to C and alpha equal to beta equal to 90 degrees. Examples of the cubic crystal is NaCl, CaF2, NaClO2, diamond copper, ZnS, etc. Then next, tetragonal crystal. In case of the tetragonal system, there are two Bravais lattice, each of which has the same collection of the symmetry elements and the lattice points. They are primitive and body centers. We already know that the primitive represented P and the body center represented I. To see the figure, simple ways represented the eight corners of the cubic and the face center in the cubic to represent the point at the center of the cubic is called the face center. In this tetragonal crystal, two length of the unit cell are equal while the third one is longer. The three axes are perpendicular. That is A equal to B, B not equal to C, and alpha equal to beta equal to gamma equal to 90 degrees. Examples of the tetragonal crystal is NiSO4, SnO2, CaSO4, etc. Then, then next come to orthorhombic crystal. In this case, orthogonal system, there are four Bravais lattice, each of which has the same collection of the symmetric elements or the lattice points. They are primitive, base center, body center, face center. Uh, in this crystal, to add the one point is base centers. Mm, to to see the figure, first one is simple, that is primitive crystal. Then next one is body center. Body center is located the center of the body, center of the cubic. Face center is represented the four sides of the cubic, and base center represented the bases. In a cubic, there are two bases are there that represented the letter C. In this crystal, the length of the unit cell are the different, but three axes are the perpendicular to the each other. That is A not equal to B not equal to C, and alpha equal to beta equal to gamma equal to 90 degrees. Examples of the orthorhombic crystal is KNO3, BaSO4, etc. Then next, hexagonal crystal. In case of hexagonal system, there are only one Bravais lattice known as the primitive hexagonal. Primitive is represented the letter P. Mm, to see the diagram, this is cubic comes under the hexagonal. Hexagonal, only one point is there, that is primitive. In this crystal, the two lengths of the unit cell are equal, one plane at the 120 degrees with each other, and the fourth axis is perpendicular to the each this plane. That is A equal to B not equal to C, and alpha equal to beta equal to 90 degrees, and also gamma equal to 120 degrees. Examples of the hexagonal crystal is SiO2, AgL, ZnO, CDS, etc. Then next, trigonal crystal. In case of the trigonal system, there are only one Bravais lattice known as the trigonal crystal, and one Bravais point is a primitive, represents the letter P. In this crystal, all the three lengths of the unit cell are equal, and they are equally inclined to the each other and the at an angle other than 90 degrees. That is A equal to B equal to C, and alpha equal to beta not equal to gamma that equal to the 90 degrees. Examples of the trigonal crystal is CaSO4, CaCO3, HGS, etc. Then next one is uh, monoclinic monoclinic crystal. Monoclinic crystal. In this case, monoclinic crystal, there are two Bravais lattices, each of which has the same collection of the symmetric elements and the lattice spines. In monoclinic crystal, there are two Bravais. They are primitive and the base center. Mm, to see the pictures, primitive is this one, random kick, and base center is that two cubic. To represented cubic, only two bases, that is this one and this one. To represent it, the two Bravais lattices, one is primitive and the base centers. In this crystal, the length of the unit cell are the different. Two axes are at right angles, and the third one is inclined, that equal to A not equal to B not equal to C, and alpha equal to gamma equal to 90 degrees, and the other one is beta is not equal to 120 degrees. Examples of the monoclinic crystal is Na2SO4, FeSO4, etc. Then last one is triclinic crystal. In case of the triclinic system, there are only one Bravais lattice known as the primitive. Triclinic crystal shows the only one Bravais, that is primitive, only cubic, only eight edges points, 8 points. In this crystal, the length of the unit cell are the different and oblique to the each other. That is A not equal to B not equal to C, and alpha is not equal to beta not equal to gamma, and Both are not equal to the 90 degrees. Example of the triclinic crystals is CuSO4, K2CrO2, K2Cr2O7, H3PO3, H2O, etc. These are the Bravais crystals, only 14 ways and the 7 crystal points. 7 crystal points are there: cubic, tetragonal, orthorhombic, hexagonal, trigonal, monoclinic, and the last one is triclinic. In these 7 crystal, there are 14 Bravais points are there. In this Bravais crystal, there are 14 ways are there, and there are 7 types of lattices. Then, to clearly explain about to see the table, to see the table and to understand the types of the lattices and the types of the Bravais panties and length and faces examples. Solid crystals, crystal, type of crystals, amorphous, Bravais crystals, types of the lattices, and there are 14 ways of the Bravais crystals are there. Thank you.